All right, so let's jump into it today. We're zeroing in on you, the Android developer, who's constantly battling deadlines, but at the same time wants to keep a finger on the pulse of the Android world and everything that's changing.
Yeah, it's a lot to keep up with.
It is. It is. We've got a whole stack of new articles and blog posts covering everything from the AI revolution that's happening right now in Android Studio to Kotlin Multiplatform insights and all those tricky permissions that can make or break your app launch.
Right. It's a lot to digest. So we're going to break it down into bite-sized pieces, pull out the key insights that you can actually use.
Exactly. And we'll make sure it's not just, informative, but also engaging too.
Yeah.
So let's kick things off with the big one, the future of Android Studio, which, by the way, is looking pretty darn smart these days.
Yeah, the AI integration in Android Studio is definitely one of the most exciting developments we've seen lately.
And there's this great blog post featuring Tor Norby, the engineering director for Android Studio. It really gets into the nitty-gritty of what's happening. And what really struck me was his personal journey. I mean, this is a guy who started out decoding magazine listings in the 80s.
Wow.
Back when you had to literally type in code from magazines to get things running.
Yeah, that's old school.
Talk about dedication, right?
It really shows his passion for programming, and you can see that same passion driving his vision for Android Studio.
Yeah.
He even mentions that he still writes code in his free time.
Wow. That's serious dedication. But
Seriously.
what I think is really cool is that, this AI integration isn't just some, futuristic concept. It's already having a tangible impact.
Absolutely. Android Studio is now using Google's Gemini AI to make intelligent renaming suggestions during refactoring.
Oh, wow.
So it might seem like a small thing, but think about how much time that saves you from manually, hunting down every instance of a variable.
It's those little efficiencies that really add up over time.
Exactly.
And this is just the tip of the iceberg, right?
Oh, yeah, absolutely. Tor talks about AI agents potentially handling much more complex tasks in the future, maybe even generating entire blocks of code based on your intent.
Wow, that would be a game changer. It's almost like having a pair programmer built right into the IDE.
Right.
I do wonder how it will impact the role of the developer, though.
It's a valid concern, but Tor emphasizes Google's commitment to sustainable development and work-life balance. So it seems their focus is on augmenting developer capabilities, not replacing them.
Okay, good to know. But let's not forget that Google also relies heavily on developer feedback to shape these features.
Oh, absolutely. The blog post actually highlights how community feedback on the issue tracker and data sharing helped them pinpoint and fix those annoying UI freezes that were happening in Android Studio.
It's reassuring to know that they're listening to us. Okay, let's switch gears now to a more frustrating topic. Those new permission policies in Google Play, specifically the Read Media Images permission. This one has been causing a lot of headaches for developers.
Yeah, it's been a bit of a pain point. It's understandable why Google is tightening up access to user media, but the implementation has definitely caught some developers off guard.
Yeah, we have a really insightful blog post from Alejandra Stamato, an Android developer who found herself in a tricky situation. With this permission she needed to display a preview of the last image taken from the camera roll. A pretty common feature, right?
Totally. You wouldn't think that would be a problem.
But the old Read external storage permission, which many developers use for this, was deprecated for Android 13 and above. So she opted for Read Media Images, which seemed like the logical replacement.
Right, and then bam, Google Play blocked her alpha release because of their stricter approval process for Read Media Images.
Yeah, it's a good reminder that Google is serious about limiting broad access to user data. But in Alejandra's case, she only needed to access the last image, not the entire photo library. It does seem like her app fell into a bit of a gray area.
It does raise the question of how Google determines what constitutes a valid use case.
So what are the practical takeaways for developers? Should we just avoid this permission altogether?
Not necessarily, but you need to be very careful first and foremost. Read Google Play's user data policy thoroughly before implementing this permission. Don't assume your use case will automatically be approved.
That's good advice. It never hurts to double check.
And always think about alternatives. Can you achieve the desired functionality without needing full media access? Maybe you can delay the feature or find a workaround. In Alejandra's case, she ended up using a hard-coded image for the time being.
Not ideal, but sometimes you have to make those compromises.
Exactly. And to avoid those launch day surprises, test your app submissions early to get feedback from Google Play.
Great advice. All right, so we've talked AI and permissions, but now let's move on to something that's been generating a lot of buzz in the Android community, Kotlin Multiplatform, or KMP for short. And we've got a real-world case study to dig into.
This is where things get really interesting. We're talking about a large-scale project with over 1,000 modules on Android and more than 150 developers. This isn't some theoretical experiment. This is KMP being battle-tested in a complex production environment.
Yeah, this is a real deal. We have a detailed blog post by Andrei Beryakov, a senior Android developer who walks us through their experience.
Yeah.
He makes a great point about the difference between developing a library with KMP and developing a full-blown product feature.
Right, when you're building a library, it's more self-contained.
Yeah.
They were able to create a WebRTC library quite successfully, for example.
But when it comes to product features, things get more complicated. You have to integrate with all those core Android libraries, analytics, deep links, dependency injection. It adds a whole new level of complexity.
And Andre goes into detail about their approach to migrating core libraries to KMP, for instance. They tackled their Android MVI flow library. Luckily, the structure of the library allowed them to extract common code relatively easily, but there were still challenges like ensuring the iOS code played nicely and dealing with diverging code bases.
It's a good reminder that KMP isn't a magic bullet. There are still bumps in the road. They also face some hurdles with their network layer, right?
Yes, they initially considered using Krator, which is a popular multi-platform networking library, but they ran into limitations with pre-configured network layers like Alamifier, which is commonly used on iOS, and the lack of support for QUIC, a newer transport protocol.
It highlights how real-world constraints can sometimes dictate your technology choices. So what do they end up doing?
They decided to build a custom network layer from scratch, which is pretty impressive considering the scale of the project. It really underscores the complexity they were dealing with.
So they put in all this effort, but did KMP actually deliver?
To measure the impact, they ran an A/B test on a small feature. The results, no significant performance difference on either iOS or Android, and no impact on build times either.
That's huge for developers who are worried about KMP adding overhead to their projects.
Right. They also noted that debugging was smooth. Incremental development worked well, and the overall experience was positive, but there were some quirks.
Oh, like what?
Publishing new versions and integrating the KMP code with the iOS build process presented some unique challenges that required them to get creative with their solutions.
So some hurdles to overcome, but it sounds like the benefits outweigh the challenges in this case. It's interesting that a year later, they shifted their focus to a back-end-driven UI framework built on KMP. It makes you wonder if this is the direction things are heading.
It's a fascinating trend. We're seeing more and more companies exploring this approach with more logic, moving to the back end. The client side could potentially become much simpler. But before we get too deep into that, let's switch gears and talk about something a little more bite-sized, some quick and actionable Kotlin tips that can instantly level up your code.
I love it when we get practical, and these tips come from Nirav Tukadia, an experienced Android architect who really knows his Kotlin. Let's start with one that can save you from those dreaded nested try-catch blocks, run catching.
Yes, run catching is a fantastic way to handle errors gracefully. It's so much more elegant than traditional try-catch blocks.
It's a game changer, for sure,
Yeah.
but there is one caveat to keep in mind.
Right. Currently, run catching doesn't catch cancellation exception. Something to be aware of if you're working with coroutines.
Good point. Now let's talk about sealed interfaces. These are a great way to enforce stricter type hierarchies across multiple files, which you can't do with sealed classes.
They're especially useful for defining state machines and data types, where you want to ensure that only specific types are allowed.
And for those times when you need a lightweight wrapper for a valued classes are your friend, they save memory compared to data classes, which is always a good thing.
Absolutely. And speaking of efficiency build list and build map, make creating immutable collections a breeze.
So much cleaner than messing around with mutable lists and maps. All right, let's move on to two little gems that I always forget about, take if and take.
These are fantastic for concise conditional assignments. They can really streamline your code.
Speaking of streamlining, modifier dot composed in Jetpack Compose can help you avoid unnecessary recompositions when creating custom modifiers.
Although it's worth mentioning that this is no longer the recommended approach. Modifier.node is now the preferred way to create custom modifiers, offering more flexibility and better performance.
It's always good to stay up to date with the latest best practices. Finally, let's talk about Kotlin's iterator function. It allows you to create custom iterators for any class, giving you incredible control over iteration.
And it's surprisingly easy to use. You simply implement the iterator function in your class, and you can then use it in for each loops just like any other iterable.
It's a powerful tool that many developers overlook.
It really is.
Well, I think we've covered a lot of ground in this first part of our deep dive.
We certainly have, from AI-powered IDEs to practical Kotlin tips and the challenges of KMP and permissions. It's been quite a journey so far. But we're not done yet. We've got more insights and actionable advice to share. Stay tuned for part 2.
So before we dive into our next topic, I just wanted to kind of pick up on something you mentioned earlier about the potential impact of AI on the role of the
We're
developer.
right when we were talking about Tor Norby's vision for Android Studio. Exactly. It's something that's on a lot of developers' minds right now. Will AI tools make us obsolete? Will they change the skills we need to be successful?
Yeah, it's definitely a valid concern. I mean,
hmm
if AI can generate entire blocks of code, what does that mean for the future of coding?
Well, I think it's important to remember that AI is still in its early stages. It's not going to replace human developers anytime soon, but it will definitely change the way we work. Instead of spending hours on those repetitive tasks, we can focus on the more creative and strategic aspects of development.
Yeah, that actually sounds pretty appealing. Less time wrestling with boilerplate code, more time solving interesting problems.
Exactly. And I think that's really what Tor and his team are trying to achieve with Android Studio, create tools that empower developers, not replace them. But let's not get too ahead of ourselves. We're talking about those Kotlin tips, and I know we have a few more to cover.
Oh, wait, let's jump back into those. We were talking about Nirav Tukadia's insights, and I know he had a great example of using modifier dot composed in Jetpack Compose to create a custom modifier for a bounce animation.
It was a really clever example, showing how you can group multiple modifiers together and treat them as a single unit. But as you mentioned earlier, this approach is no longer recommended.
Right, modifier.node is the way to go.
Yeah.
Now, apparently it offers better performance and flexibility.
It's a good reminder that things are constantly evolving. We always have to be learning and adapting, but I think that's part of what makes it so exciting. There's always something new to explore.
I completely agree. Okay, so what other Kotlin tricks did Nirav have up his sleeve?
Yes, he talked about the power of Kotlin's iterator function.
Mm.
It lets you create custom iterators for any class, making them iterable in for loops and other scenarios.
I always forget about that feature. It's so
Mhm.
simple, but so powerful.
It really is. He gave a great example of creating a custom iterator for a number range class. It's amazing how much control Kotlin gives you over iteration.
Yeah, I'm definitely going to try that one out in my next project.
I encourage you to. Oh, and there was one more tip I think is worth highlighting. Remember build list and build map.
Oh, yes. Those are such lifesavers when you're working with immutable collections.
They really are. They eliminate the need to, create mutable lists or maps and then convert them to immutable versions later. It's all about writing clean and predictable code.
And speaking of clean code, Nirav also reminded us of the elegance of take if and take. Unless for concise conditional assignments, they can really streamline your code.
Absolutely small but mighty. And of course, we can't forget about run catching for graceful error handling. It's so much more elegant than nested try-catch blocks.
Yeah, though we should probably reiterate that it doesn't catch cancellation exception, just a little reminder for those working with coroutines.
Right. It's important to be aware of the nuances. Okay. I think we've squeezed all the Kotlin goodness out of Nirav's article. What's up next on our deep dive agenda?
Well, remember those pesky read-meaty images permissions we talked about earlier? It turns out that Google has actually published some examples of acceptable use cases for that permission in their user data policy.
Oh, that's helpful. It'd be great to have some clarity on what they're looking for.
So according to the policy, the primary use cases they're approving are gallery apps, photo editing apps, and social media apps with image sharing features. Basically, apps where accessing user images is a core part of the functionality.
Makes sense. They even specifically mention Instagram as an example. So if your app falls outside of these categories, you're going to need a very strong justification for using read-meaty images.
And even then, approval isn't guaranteed. It really underscores the importance of thinking carefully about permissions and user privacy.
Absolutely. So for developers who are considering using read-meaty images, what are the key takeaways?
First and foremost, carefully evaluate your use case. Don't just blindly add the permission to your manifest and hope for the best.
And if you're unsure whether your use case will be approved, test it early, submit an update with the permission as soon as possible to get feedback from Google Play.
That way you avoid any last-minute surprises and always explore alternative solutions. Maybe there's a way to achieve the same functionality without needing such broad access to user media.
It's all about finding that balance between functionality and user privacy. Speaking of navigating complex landscapes, we haven't touched on localization yet. It's such a crucial aspect of building apps for a global audience.
And we have a great guide from the Ryan Panthy, a software engineer who really dives deep into the world of localization in Jetpack Compose. He specifically focuses on the per-app language preferences, API introduced in Android 13.
Ah, yes. That API really simplifies how we handle app-specific language settings. Users can now change the language for your app independently of their device's overall language setting.
It's a much more user-friendly approach, no more fiddling with custom language pickers or manually saving user preferences.
Right, the system takes care of most of the heavy lifting for us, but Narayan also provides some great examples of how to customize the experience if you need to.
Yes, he shows how to create a custom Attico Manager class that handles language selection and interacts with the per app language API. So even though the system provides a lot of automation, you still have that flexibility to tailor the user experience.
It's the best of both worlds. And speaking of making things easier, Narayan also highlights a handy Gradle feature, the generate locale config property.
Oh, that's the one that automatically generates locale configuration based on the localized resources you've added to your project. It saves you from manually creating those local config.xml files.
It might seem like a small thing, but these little time savers can really add up. And ultimately, that's what we're all striving for, right? To make our lives as Android developers a little bit easier and more efficient.
Absolutely. And speaking of efficiency, remember when we were discussing how KMP might simplify the client side? They got me thinking about the future of state management patterns.
Oh, interesting. Are you thinking about how a simpler client might impact the need for complex state management solutions like MVVM or MVI?
Exactly. And luckily, we have a video from Philip Lackner, an Android developer and content creator, who delves into the pros and cons of both MVVM and MVI.
It's always a hot topic in the Android community. Everyone has their preferred approach.
Right. And Philip makes some great points about the differences between how these patterns are typically implemented with MVVM. You often have individual state variables for each field in the view model, while MVI usually bundles all the screen state into a single data class.
Yeah, it's interesting how those subtle differences can impact the way you structure your code. So which approach does Philip prefer?
Well, he highlights some advantages of MVIs, especially when it comes to initializing the view model and passing state down to the UI in Jetpack Compose. It avoids having those long lists of arguments for your composables.
That's definitely a plus, but he also acknowledges the flexibility of MVVM when it comes to combining and deriving states reactively. He gave some nice examples of using the combine operator to create derived states based on changes in other states.
And he pointed out potential performance benefits with that approach, because you avoid unnecessary recalculations when unrelated state values change. It seems like there are trade-offs with both approaches.
There always are, and ultimately, Philip doesn't declare a clear winner. He even admits that he uses both patterns depending on the project. He tends to favor MVI and Jetpack Compose projects and MVVM in traditional XML-based projects.
I guess the key takeaway is that there's no one-size-fits-all solution. It's about understanding the principles of state management and choosing the approach that best suits your project and your personal preferences as a developer.
Couldn't agree more. It's about being pragmatic and finding the right tool for the job. So where does that leave us with our original question about the future of state management in a world of potentially simpler clients?
That's a great question.
Yeah.
And one that I think we'll need to explore further, but we've covered a lot of ground in this second part of our deep dive.
We certainly have, from Kotlin tips and permissions to localization and the intricacies of state management. It's been quite a journey.
But we're not done yet. We have one more part to go. So stay tuned for the grand finale of our deep dive, where we'll tie everything together and leave you with some final thoughts to ponder. Okay, so we're back for the final part of our deep dive into the world of Android development. It's been a whirlwind tour, but I hope you're feeling as energized as I am about all these new tools and techniques.
Yeah, we've covered a lot from AI-powered IDEs to practical Kotlin tips and, navigating those tricky permissions to understanding the ins and outs of state management. It's a lot to absorb.
It is, but I think we've done a good job of, really distilling down those key insights and those actionable takeaways. And that's ultimately what this deep dive is all about, helping you stay ahead of the curve as an Android developer.
Right, we want to equip you to make, smart decisions about the technologies and approaches that you're using in your projects.
So in this final part, let's try to kind of connect the dots and see if we can maybe answer that question that we posed earlier. Will back-end-driven UI frameworks and a potentially simpler client side, will those things make those complex state management patterns like MVVM and MVI obsolete?
Yeah, it's a fascinating question to think about, and I don't think there's a simple yes or no answer, but it's definitely a trend that's worth keeping an eye on.
I agree. As more and more logic moves to the back end, The client side might become, primarily focused on display logic and user interactions.
Right. And if that's the case, do we really need all the complexity of MVI or MVVM? Maybe simpler state management solutions will kind of emerge that are better suited to this new paradigm.
Yeah, it's definitely possible, but I also think it's important to remember that Android development is such a diverse ecosystem. Not every app is going to, follow this trend towards back-end driven UIs.
Yeah, that's a good point. There will always be apps that require, that complex state management on the client side, things like games or apps that need to work offline.
Right. So I don't think we'll see, MVVM or MVI disappear completely, but their role might evolve, as the landscape changes.
It's all about adapting to change, which is something as Android developers we're pretty good at.
Absolutely.
Mm.
I mean, we've seen so many changes over the years from new programming languages to entirely new UI frameworks. And, we've always found ways to adapt and thrive.
It's that spirit of continuous learning and innovation that really makes Android development, such a rewarding and exciting field to be a part of.
Couldn't agree more. And I think
Yeah.
that's a great note to end on.
Yeah. So as we wrap up this deep dive, I want to leave you with a final thought.
Obito.
Don't be afraid to experiment, to try new things, to challenge the status quo. That's how we push the boundaries of what's possible in Android development.
I love that. So to all you Android developers out there, stay curious, keep learning, and keep building amazing apps.
And until next time, happy coding.